Over the last year or so, Avid CNC has been sending me new bits for my CNC machine, which has been super awesome, but I haven't found the time to install any of it. So my plan now is to do all of these little projects on the CNC as one big project. So there were things that I need to change out on the machine, and there are a few things that I've been wanting to do. So first I unpacked the boxes that I've received and tried to figure out what I had and what I was going to need to change. They sent me a new Z axis. I think I had a 12-inch axis before, and that was really more than I needed, so I have an 8-inch. New side plates for the gantry. New pinions for the rack and pinion on the 3 different axes. And the big thing, and what's kind of making me do this at this point, is a new spindle. So this is their new 8.7 horsepower spindle, I think, which is a beast. So it was a matter of figuring out the new parts and at what edge do I take my current machine apart to, and what old parts do I have that I can scavenge from if I need to. So the first thing in dismantling the old machine is I started to take the dust collection off. Then I can take the spindle and the Z-axis off. You can see this Z-axis is really, really tall. So this spindle's been great, but it'd be fun to have something bigger. So I'm holding it with my shoulder here as I take the last screw out. So a big part of this project is taking bolts out and putting bolts back in again. I can take the motor off the gantry, or the gantry carriage, I guess, or gantry trolley, yeah. So this is a time lapse of taking everything off the gantry. One of the new things to add is the new sensors, and the sensors that go on the base of the gantry attach to the plates at the base of the gantry, and there's some new threaded holes that are in that plate. So what I need to do is take the motors and these plates off and switch them out for the new ones. So I held the gantry up on some blocks of wood so I can take these plates out. So this is the new gantry plate. I guess that's what I would call it. I'm not really sure what the technical term for this is, but it's just a matter of reattaching it. It seems to work. Then I can slide it in next to the gantry. This was the one tricky part, in that when you assemble the machine, when you're building it, you sort of slide this plate onto the 80-20 column, and it makes it all really easy. Whereas doing it this way, I have to line the bolts up with the little inserts that go in the 80-20. So getting those in the right place. I used my phone sort of as a mirror so I could see what I was doing, which also made for some nice video to see what I was doing. I needed to see that the little threaded insert was in the right location, so the bolt would hit it right and thread correctly. So I did both sides. I think I just filmed one side, but I did both sides. Then I replaced the pinions on the rack and pinion gears, and to get the belt back on again, I had to loosen up the motor, as it can slide back and forth in its mounting spot, which lets you get the belt put on. Once the belt is in place, you can move the motor with a little cam that tightens up the belt. Once that's tight, you can tighten up the bolts that hold the motor in place. There's probably a precise tension for the belt, but I just kind of do it to where it feels about right. Then I can attach the entire motor assembly back onto the gantry plate. The motor kind of swings on that secondary plate. Then there's a threaded bolt with a spring that works as a tensioner to hold the pinion against the rack gear. And this allows the gear to slip if you run into anything, because these motors will chew up the gear if they don't have any give. One of the things I wanted to do was to put on a new spoil board, and to do that I needed to take my end table off. Then I have a piece of hardwood, I think it's maple, that goes on the end of the MDF. And it was there to allow the screws for the hinge to bite into something a little denser than the MDF. Then I can take the spoil board off, which is held on by a bunch of little bolts and holes. I probably could have gotten a little more use out of this spoil board, but as I was working on everything else, it seemed like a good time to change it out. Also, I wanted to find a use for it instead of just throwing it out. Then the neglected CNC computer was getting a little bit dusty, but it still seems to work fine. Then I removed the electronics box for the old spindle, as I don't need that anymore. With as much weight off of the frame at this point, I've wanted to move the entire machine over about 4 inches. So I lifted it on my cart just enough to where I took some of the weight off of the feet, and I could sort of slide the whole machine over. And as I moved it, I wanted to recheck that the top surface was planar. So I can run a string between the 4 corners, and if the center of the X just touches each other, then it should be planar, as in the 2 side rails are coplanar. Another little issue with the frame, as the machine moves around, it tends to jiggle the whole frame just a little bit. It isn't too bad, but I thought it'd be nice to see if I could stiffen up the table that the machine sits on. So I remembered that I had all of this aluminum C-channel that I had saved from the pool cover from the original pool building that we took out to build the shop. And I knew one day I would find a use for it. And here we are, 10 years later. This was a lot of fabricating pieces, meaning cutting the ends and drilling holes. One of the things I wanted to do with this new frame was to build a platform underneath the table so I could put a lot of weight down there to sort of hold the machine down. And my thought was to put a bunch of drying wood slabs under the table. Also, I set up the drill press in my little metal shop and finally got that running again, which works perfect for drilling aluminum. I started to build the platform under the frame. You can see how these inserts work, where you don't have to get to the end of the channel and the 80-20. You can just put these wherever you need them. They work as the nut on the end of the bolt to attach things to the 80-20 extrusions. Then for the platform pieces in the middle of the table, I drilled holes in the side of the channels. And those can go on the bottom of the frame. Most of the pieces I had were right around 8 feet, so I had just enough length to reach across the table. Originally, I had thought I would make sort of a shear wall down the center of the underside of the table, but I ended up not doing that, and I thought it would functionally be a little nicer to keep the inside of the table clear to store the wood slabs, and I'd put bracing around the outside of the table. So I cut some pieces that would run at a diagonal, sort of bigger versions of what comes with the table. And I figured out the sort of length and shape that those needed to be. I also thought it'd be better to use my bigger chop saw, and maybe someone makes a blade for cutting aluminum. So I did a little research, and yes, they make a blade for cutting aluminum, which worked a little better. There was one set of cuts that needed a tighter angle than the saw would do, so I had to clamp the aluminum away from the fence. But this is where having the bigger saw and the aluminum blade really helped, as I had a long cut to make. And I drilled holes in these pieces. This was a little tricky, figuring out where the holes needed to be. I got them close and I oversized the holes just a little bit, so I would have a little bit of adjustment. So I'm sort of making a truss out of the side of the table. And I can tighten up all of the bolts. I finished up the platform on the underside of the table. I had originally thought I would use the spoil board as the center spine sort of shear wall under the table. Since I wasn't going to do that, I thought maybe I could cut half the spoil board up into furring strips for the lumber I was going to put under the table. So I cut the spoil board into a bunch of strips. Another problem I was having that I thought I could solve with this CNC project was that the oak that I cut last fall looks like it's starting to split in places. More than just checking on the end, but actually starting to crack. And I'm thinking, because this oak has so much water in it, and it seems to move quite a bit as it dries, having the slabs be so thick. We cut them at 2.5 to 3 inches thick, that maybe making them thinner would be a good idea. So what I thought I would do is process some of it down to smaller pieces. So I started by cutting off the outer edge, then following the center where most of the cracking seemed to be, and cut these slabs in half. You can see how cupped and sort of warped this piece is already, and it's still pretty wet. Also, this will mean these pieces will dry a lot faster. A year or two instead of 5 years. All of this work getting the slabs ready was really just the pre-work before the actual project, which was to cut these down to thinner pieces. It wouldn't be so thick. On some of them, the section near the center, if I cut off a strip, I'd have a nice quarter sawn piece by looking at the grain direction, and it would straighten up that edge. Then I could resaw the rest of the piece into 2 nice and still 5 to 6/4 thick pieces that I can put under the CNC table and sort of forget about. And hopefully they'll be thin enough now where they won't crack, and they'll dry somewhat quickly. I put some of my furring strips down, and I can start to lay the pieces of oak under the CNC table. I've found over the years I really haven't kept much under the table. I always figured it'd be a good place for storage. It's sort of hard to get to, and it just gets dusty, and maybe if I just fill it up with wood and kind of forget about it, then that would really be a good use for it. So I kind of laid out the wood as best I could. I got to a certain point here where my bandsaw blade kind of gave out, so I had to wait a few days to get that replaced. So I did just a little bit more wood than what was here. I definitely didn't fill the space. I didn't want to put too much weight on those cross pieces under the table. Now it's time to put the new Z-axis and spindle on. I brought a piece of the old spoil board over just as a work surface. I can put the new Z-axis on. See if you can tell what I'm screwing up at this point. And I can put the motor back on again. And the motor on the Z-axis goes in the top. And I have a new Z-axis cable routing thing, cable track. That'll be kind of nice. There's a plate that goes on the back of the spindle, and a different plate that goes on the Z-axis, and then you sort of marry those two plates together, and that's what connects the spindle. And it gives you some adjustment to the verticality of the spindle. So I was standing on the side putting this on and didn't notice that I wasn't centered on the gantry trolley. You can see it from this view. So I put all these parts on and it wasn't quite in the right place. And the bolts that hold the Z-axis to the trolley are at the very bottom. So I ended up having to take all of this apart, move the Z-axis over one column of screws, and put everything back on again. It went faster the second time, but it was still kind of a pain. So here's me moving it over after I've taken everything off. And there's a new spindle electronics box. I can bring over the new spoil board. I bought a couple of months back, before prices started to get too insane, a 1-inch thick piece of MDF, which I hope will give me deeper slots for my hold downs and will give me more thickness to be able to resurface the top more times. Before I attach the new top, I thought maybe I should check the spindle for verticality. And it'd be fun to actually see the spindle come on and cut something. So I mounted one of the end pieces of oak to the frame of the table, as I didn't really have a way to hold this down yet because the spoil board wasn't finished.
Continue with the operation. You may fire when ready.
What?
Commence primary ignition.
And I could test the new spindle, which cuts amazing. It is clearly a lot more accurate and a lot more powerful than the old spindle. Also, with no dust collection, it makes a huge mess. Even just taking off a little bit. So in running it with a wide bit and with a big step over, if you get any ridges between the cuts, you know that your spindle isn't quite square to the table. So I trued that up as best I could, and it definitely got a lot better. And I cut a little more. It was just getting way too sawdusty without the dust collection in place. And there's no table, so the sawdust is just kind of going everywhere. I ran a flattening pass in the other direction, and the spindle seems to be square in that direction. And I cleaned up that piece and took it off. I can start to mount the spoil board to the frame. I can drill all of the holes for that. I'll use the same system I had before, where there's sort of a big hole, then a sort of a slot cut in the bottom of that hole that the bolt goes through. So this buries the head of the bolt well below the surface of the table. I put the spoil board up on furring strips to cut those holes. Then I can just take those out and lower the table and put all the bolts in. As I've done this before, and I have a file that puts the holes in the same places as my cross pieces, everything for the most part lines up, and it's just a matter of putting all the bolts in. Then I can start cutting the slots in the table. So I'm going to just do the same system I had before, which worked pretty well, where I just have a bunch of short slots in the table, and I cut a bigger circle at one end of that slot. Then I cut a T into the bottom of that slot, and that lets me use my hold downs. And I'm hoping with this thicker MDF, I'll get more holding strength. As in, I can tighten the hold down knobs more with this thicker piece of MDF to hold on to. And I can put the angled end table back on again. So you'll notice that I'm using the same piece of hardwood at the end, and I'll have a little bit of a height difference between the end table and the main table. But what this will allow is that I can resurface the spoil board without hitting the hinge that holds the end table on. If I ever need to do anything that's longer than 8 feet, I can just kind of shim the end up on the end table. So far, I haven't had to cut anything longer than 8 feet, so I'm not super worried about it. And this puts the center of rotation of the table in the same location, so my arced pieces on each side still work. So that's the upgrade to the CNC machine. I still need to do the dust collection, and I need to flatten the table. And with the little bit of use I've done so far, the table does seem to jiggle less. That's probably some of the bracing I've put on, the weight that I added, and that I've upgraded to Mach 4. Thanks for watching.